Welcome to our YouTube channel. This is Ernest coming to you from MathLab Tutorials in Toronto, Canada. Our mission impossible is simply to convert some of that math hate to math love. As your screen says, like it or not, math really did take us from the Flintstones era to the Jetsons era. There is no doubt about that. Now let's get down to some serious math. This is video 5 of the BEDMAS series, and I encourage viewers to have a look at the previous videos to this one to make sure you understand what's going on. In this video, we're dealing with multiplication and addition of fractions put together, and we'll see how that pans out. Let's look at Q1, question 1. It says simplify the fraction string to obtain the final result. We have bracket -1/2 dot 4/3, all in brackets. Because there's a dot in between the two fractions, we recognize this is as a cluster, and of course there's only one cluster. So there is no DMF. There are no fraction strings inside the brackets, so we don't have to simplify inside the brackets. They're already simplified as they stand. So we're ready to do a neg count for the entire cluster. We do a neg count of 1. And of course, a neg count of 1 means that the result is negative. So there's the negative sign right there. You disregard all the negatives and bring the fractions down. You get 1/2, bring it down, 4/3, bring it down. Now, when you bring it down, you can automatically multiply the numerators together. So you can write down 1.4 and then multiply the denominators together, you get 2.3. Because when you multiply fractions together, you can, one way of doing it is to do numerator times numerator, denominator times denominator. And when you do that, we wind up getting minus 1.4 over 2.3. Then you evaluate each expression in the numerator and denominator. You bring the minus sign with you. 1.4 is 4 and 2.3 is 6. And of course, minus 4/6 is a proper fraction, but it can be reduced. You can divide top and bottom by 2. When you do that, you get minus 2/3. So that's fairly straightforward. Let's go on to the next slide. Let's look at question 5, which is a considerably more complicated fraction string. We have bracket -1/2 dot bracket 2/3 plus bracket 1/6 dot bracket 3/4 plus bracket 1/8 dot bracket -2/3. Now, first of all, notice there are no DMFs inside the brackets. You don't have to do anything first inside the brackets. Everything is simplified inside the brackets. Single fractions. So there are no DMFs in this problem. The next thing you notice is that there's a dot there, so that forms a cluster. The plus sign is a separator between clusters. There's a dot there, so this forms a cluster. And then there's a separator between the clusters. Do you remember the separators are allowed to be positive or negative? In other words, a plus or a minus sign. And again, for the third one over here, we have a dot between the brackets, so this indicates a third cluster. So when we look at the entire expression, we identify 3 clusters, and the neg count for this is 1, the neg count for this is 0, and the neg count for this is 1. Now, 1 is odd, so the result is negative. 0 is even, the result is positive. And 1 is odd, so the result is negative. So the clusters are negative, positive, negative. And there they are right here. There's the negative sign right there. And then you can do a 1.2, drop it down, 2.3, drop it down. Then this cluster over here is positive. There's the plus sign. And you can do 1.3 over 6.4, 1.3 over 6.4. And then this cluster over here is negative. So you put a minus sign down. and you can do a 1.2 over 8.3. And now we simplify each cluster. You drop the minus sign down, you get a 1.2 is 2, there it is. 2.3 is 6, there it is. And then we'll go on. A 1.3 is 3, there it is. 6.4 is 24, there it is. And then drop the minus sign down. And then a 1.2 is 2, and an 8.3 is 24. Now you'll notice that 2 over 6 can be reduced. 2 divided by 2 is 1, 6 divided by 2 is 3. So we write down negative 1 over 3. 3 over 24 can be reduced. 3 divided by 3 is 1, 24 divided by 3 is 8. So that reduces to 1 over 8. And 2 over 24 can certainly be reduced. 2 divided by 2 is 1, 24 divided by 2 is 12. So you can drop down the 1 over 12. And again, we have a minus, plus, minus, as indicated over here. Minus, plus, minus. And now we have a simple fraction string. And we look at the denominators 3, 8, and 12. And we conclude that the lowest common denominator of 3, 8, and 12, if you think about it carefully, it'll be 24. And in the next line, we draw a big or a long fraction bar, put the denominator on the bottom, and put all the numerators on top. We do negative 1 dot empty bin, plus 1 dot empty bin, negative 1 dot empty bin. And like we did in the past, we're going to fill in the empty bins using the LCD. 24 divided by 3 is 8. Drop the 8 down. 24 divided by 8 is 3. Drop the 3 down. And then 24 divided by 12 is 2. Put the 2 inside the bin. Now the bins are all full. And we have a fraction, not a fraction string, sorry, an integer string basically on top. And we get a minus 1.8, which is negative 8. 1.3 is 3. Negative 1.2 is negative 2. On the bottom, we have the LCD, which is 24. And on top over here, we have 3 good guys and 10 bad guys. So we write down 3 minus 10. And of course, the bad guys win over here by 7. Because the bad guys win, we put a negative sign out front. Now, the negative sign could have been kept with a 7, or could be brought to the central location over here. Okay, either or, it doesn't really make any difference. The value of the fraction remains the same, so the minus sign could either be brought out front, or it can be left with a minus 7, your choice. And then we see that minus 7 over 24 is improper, or sorry, is a proper fraction, but it's irreducible, cannot be reduced. So that means that that's the final answer. Let's go on to the next slide. Now, part C over here, we're dealing with division and addition of fractions. Let's go through some rules first over here. The division rule. It says when you have a fraction like a over b divided by another fraction c over d, what it's equal to the first fraction untouched, and that division sign becomes a multiplication sign, and you flip the fraction. Okay, let's go over it again. You have a over b divided by c over d. The first fraction remains the same. Just do a copy-paste. The second fraction gets flipped, and the division sign turns into a multiplication sign. I call that the keep dot flip rule. Keep, because you keep the first fraction the same. Dot, because the division becomes multiplication. Flip, because the second fraction gets flipped. So it's keep, dot, flip. Okay? So it's keep, that becomes a dot, and that becomes a flip. Keep, dot, flip. I often abbreviate that as K dot F. K dot F for short. Okay, so if you ever see that in any of my following videos or any videos to come, K dot F means keep dot flip. It's the division rule for dividing fractions. Here's some simple examples. You have 1 over 2 divided by 3 over 2. keep the first fraction intact, the division becomes a dot, and the second fraction gets flipped. And then you know how to multiply fractions together. You do 1.2 on top and 2.3 on the bottom. 1.2 is 2 and 2.3 is 6. And then 2 over 6 is a proper fraction, but it may be reduced. Divide top and bottom by 2, and you get 1 over 3. And that's the final answer. Let's look at another one. Minus 2 over 3 divided by minus 3 over 4. Again, we have two fractions this time, but they're both negative, so don't worry about the negatives. Actually, what I ask my students to do is worry about the negatives right away. Sorry, let me back out of that one. Anyway, what you do is do a neg count. It doesn't matter whether you have division or multiplication between the brackets, you can still do a neg count. As long as you don't have a DMF over here. Over here, if we have multiple terms, we have to do a do me first. In other words, we have to resolve the multiple terms first. But over here, we have a single fraction. Everything's been done for us. So whenever we see a division sign or a multiplication sign, we're ready to apply the neg count rule. When we count the number of negatives, we get 2, and 2 is even, so the result is positive. Next, what you do is drop all the negatives as usual, and we're going to do a keep dot flip. You keep the first fraction 2 over 3, the division becomes a dot, and the second fraction gets flipped. And then at the end over here, we can drop the plus sign as usual. Or we can do a 2.4 and then 3.3, which is 3.3. And then 2.4 is 8 and 3.3 is 9. 8 over 9 is between -1 and 1. So this is a proper fraction and it's irreducible, cannot be reduced. So that must be the final answer. So let's go on to the next slide. And let's do another question over here, Q1. And we have -1 over 2 divided by 4 over 3. Again, this is a division symbol between the fractions, so we declare this to be a 1 cluster. And we can do a neg count. The neg count is 1, and 1 is odd, so the result is negative. See, we identify 1 cluster, the neg count is 1. That implies, this is called the implication symbol, implies that the result is negative. So I'm going to start, as we keep on going through these videos, what I'm going to do is start abbreviating things more and more. So that's where it's really important that you go through my videos in sequence, okay? So you get used to my notation, because the notation that we use over here might be substantially different to what you're used to in school. So I urge you to go through the video series that we present in ordered sequence. Okay, so I really encourage that. Anyway, the neg count is 1, so the result is negative, so we put the negative sign down. Then we disregard all the negatives as usual. We drop the first fraction down, so we keep the first fraction. The division becomes a dot, and we flip the second fraction. So that's an example of keep dot flip. At the end, we bring the minus sign over, and we get a 1.3, which is 3, and 2.4, which is 8. 3 over 8 is proper, and it's irreducible, so this would be the final answer. Let's go on to the next slide. We have a substantially more complicated problem over here, so you've got to pay even closer attention. If we look at the global picture over here, like the bird's eye view of what we have, the division sign between the brackets means we have a cluster here. The division sign between the brackets, we have another cluster here. Division sign between the brackets, we have another cluster. So we're allowed to do a neg count for this cluster, and this cluster. We have a plus sign over here as a separator between these two clusters. The plus sign is a separator between this cluster and this cluster. Okay, so we identify 3 clusters. We can do neg counts for each cluster. The neg count for this one is 2. The neg count for this is 1. The neg count for this is 1. 2 is even, the result is positive. 1 is odd, 1 is odd, so the result for the second and third clusters are negative, negative. So the clusters are positive, negative, negative. That's the final result there. So we'll keep on going. We put a plus sign because the first cluster is positive. Disregard all the negatives at this point, and we're going to do keep dot flips here. You keep the 1/3. The division gets replaced by a dot, and you flip the fraction to get 3/2. This cluster was negative, so we put a negative sign down. Keep the first, disregard all the negatives henceforth. Bring the fraction down, bring the first fraction down 1/6. The division sign gets replaced by a dot, and the second fraction gets flipped. This cluster was negative. Bring the first fraction down, just keep it. The division becomes a dot, and you flip the second fraction to get 4/1. So we've done all of our neg counts, and we've done all of our keep dot flips. Now what remains is to do some multiplication over here. The plus sign gets dropped down. We get a 1.3, which is 3. There it is. And 3.2, which is 6. There it is. And over here, this cluster is negative. Drop the negative sign down. Do a 1.2, which is 2, and 6.3, which is 18. This cluster is negative. Drop the negative sign down, and you do a 1.3, which is 3, 4.1, which is 4. 3/6 can be reduced. Divide top and bottom by 3. 2/18 can be reduced. Divide top and bottom by 2. And 3/4 cannot be reduced. Okay, so make sure you reduce all the fractions first. Drop the plus sign down. This reduces to 1/2. Drop the minus sign down. This reduces to 1/9. Drop the minus sign down. This is already reduced, so drop it down as 3/4. At this point over here, we need to do the LCD part. We look at the denominators and conclude that the LCD of 2, 9, and 4 is 36 because each of these denominators divides evenly into 36, and 36 is the smallest number that does the job, so we conclude that that's the LCD. In the next step, big division bar, big horizontal bar for the division bar. Pick up the LCD over here, drop it down, put it in the denominator, and now it's time to deal with the numerators. Over here you get a 1, so you do a 1 dot empty bin. -1, so you do a -1 dot empty bin. -3, so you do -3 dot empty bin. Picture those bins to be negative for the time, or to be empty for the time being. Okay, now it's time to fill in the bins using the LCD. 36 divided by 2 is 18, fill in the bin. 36 divided by 9 is 4, fill in the bin. 36 divided by 4 is 9, fill in the bin. And as usual, the numerator is essentially going to become a fraction string. Okay, we get a 1.18 is just 18, -1.4 is -4, -3.9 is -27. If we look at the numerator, we get some good guys and bad guys. Specifically, we get 18 good guys, 31 bad guys. And we conclude that the bad guys win. So you put a negative sign there. And then 31 minus 18 is just 13. 13/36 is a proper fraction, and it's irreducible. So we conclude that this is the final answer. Let's go on to the next slide. Again, this is just to review BEDMAS again. B means brackets, and then we do exponents. Okay, brackets come before the exponents. So B and E should really group together. Then comes division and multiplication next in the order of priority. And then lastly comes addition and subtraction third. So this is just a review about BEDMAS, the order of operations. So we can go on to the next slide. And over here, we're going to be using BEDMAS with fractions. But I think this video is long enough, so we're going to do an over and out. Thanks to all for viewing this video. Stay tuned for many more to come. If you liked the video, please give us a like and subscribe to our channel. If not, tell us how to improve it. Over and out from MathLab Tutorials in Toronto.